Let's work on sine and trig functions in the real world, because one question you guys may have questioned or asked or thought about was, how is this used in the real world? So let's look at sine specifically. So previously we determined that sine of an angle, so sine of theta, is equal to the opposite side of a triangle divided by the hypotenuse side of the triangle. So now let's look at this in a real world scenario here. So let's say we have this nice tree, and we'll say it's an oak tree, and that doesn't really matter, but we're just going to use it for aesthetics, I guess, just to add a little bit to the story here. And let's say it's a nice, beautiful, sunny day, and the sun is out and sun's beaming down everywhere. Now, in this instance, the tree would be casting a shadow here. All right, let me make the shadow black. It's a bit easier to see. But the tree here is casting a shadow. And let's say we know that this tree is a total of 16 feet tall. So let's say the tree is 16 feet tall. And let's say we know that the sun is beaming down on the tree at, I don't know, we'll say this angle is 48, and we'll say that you threw a rope up into the tree and you pulled it down until you reached the edge of the shadow and used a protractor, and you said this was 48 degrees. The sun is beaming light down at 42 degrees, but we're going to use this 48 degree angle here. And we know this is going to be 90. So, 90. Okay, so what if we want to find this horizontal length here for whatever reason? Alright, so we're going to find and solve for x. Well, how would we set this up? We have three angles. We have one known side and one unknown side. Now, we could get the sine of 42, but we don't know this opposite side here. This is a mystery. Alright, in fact, now, this is a mystery. But we do know that this side 16, and we don't know this hypotenuse. So how will we set this up? Well, we can say the sine of 48 is equal to 16. And the reason why we're using 48 is because the opposite side, since we're using sine, the opposite side would be 16. And the hypotenuse would be x. So we don't know that, so we're going to do 16 over x. Now, how do we solve for x? How do we solve for the unknown side? Well, if we say sine of 48, we can actually rewrite this and use cross multiplication. So we can say sine of 48 over 1 is equal to 16 over x. Now this is solvable because we can use cross multiplication. 1 times 16, well, that's equal to 16. And then sine of 48 times x. So then we get sine of 48 times x is equal to 16. Well, how do we solve for x? Well, we can use basic algebra to solve for that missing side x. So we can divide by sine 48 on both sides. And we know now that x is equal to 16 divided by sine 48. And if we did the math, we can actually determine, so 16 divided by sine of 48, and we get a wacky decimal, 21.5. So we know this is equal to around 21.5. And we're just going to say it's 21.5. So we now know that this length of the shadow is 21.5 feet. Now let's look at a different example here. Instead of using this nice beautiful tree that I drew here, let's look at, I don't know, let's kind of do the same thing. So it's a sunny day, all right, and sun's out, it's shining its light everywhere, it's bright, and you're walking through the park and you see a flagpole. Now, let's say you want to determine Here, let's keep this red. Now let's say you want to determine the height of this flagpole. So let's say the height of this flagpole is x. Let me draw that x a bit better. So the height of the flagpole is x. And of course the flag is casting a shadow. And we're going to say that this angle right here, we're going to say this is a 30-degree angle. And let's say we, for some reason, know that from this point here to this point here, we're going to say this is 10 feet. All right. Now, if this is 30 degrees, we can solve for the rest of the triangle. But how do we find for the height? Well, we can't say the sine of 30 because, well, here's the thing. We don't know the opposite side, just like the last scenario. That's unknown, so we can't use that. So we have to get the sine of this angle, because the sine of this angle here is x over 10, because sine is opposite over hypotenuse. The opposite side of this angle is x, and the hypotenuse is 10. But what is this angle? Well, we know that this is a 30, 60, 90, because we have a 30. We have a 90-degree angle, so this must be 60, and that all adds up to 180. So the sine of 60 is equal to x over 10. Now, how do we solve for x? Well, just like the last time, we can rewrite this as sine over 1 is equal to x over 10. And now we could do cross multiplication. So 1 times x, 1 times x is just equal to, well, x. And then sine of 60 times 10, well, we're going to say this is approximately, and we're going to do sine of 60 times 10, and that's like 8.6. So we're going to say just use 8.6 here. So now we can say x is equal to 8.6, meaning that the height of the flagpole is 8.6 feet. So it's a fairly short flagpole, short for a flagpole. Typically they're a bit taller than that. But we now know the height of the flagpole is 8.6 feet. Now, many people probably don't know this, but these trig functions like sine, cosine, and tangent aren't just limited to finding the heights of flagpoles or trees and all that stuff. It's actually used in a lot of modern technology, specifically graphics rendering for, your video games, or advanced 3D models for, machinery and stuff like that. It's used a lot for computer graphics and stuff like that. And even these simple calculations do so much for these graphics and allow computers to output a proper image and do all these calculations for it. But that is how we use, or how you could use, the sine trigonometric function in the real world. I hope this helps broaden your understanding on what sine is and its capabilities, as well as other trigonometric functions.